choosing a primary key for your database. It seems like such a simple decision, right? But it's one of the first, most fundamental choices you have to make. And believe me, it can have massive consequences for your application's performance, its scalability, and even its security down the road. And this isn't some academic debate we're having. This is a real-world problem that developers slam into every single day. This post from Reddit user developer 1408 just perfectly captures that moment of indecision that, let's be honest, so many of us have felt. So here's our game plan for this. First, we're going to break down the dilemma itself. Then we'll look at the two classic contenders, uncover a really nasty hidden performance trap, introduce a modern solution that might just be a game changer, and finally, give you a practical framework to make the right choice for your project. Okay, let's dive right in. The developer's dilemma. Choosing an ID isn't just about making sure every row has a unique number. No, it's a core architectural decision. If you get it right, your system can scale beautifully. But if you get it wrong, you could be fighting performance fires for years to come. And this brings us to the two traditional contenders in the ring, Team Integer and Team UUID. Now, each one has its loyal fan base. And for really good reasons. They both solve that core problem of uniqueness, but they do it in fundamentally different ways. So this slide really frames the classic way of thinking, doesn't it? On one side, you have integers. They're the go-to for simple, single database applications, the reliable workhorse. On the other side, you've got GUIDs, the modern solution, built for a world of microservices and distributed data, where you need to create IDs anywhere, anytime, without asking for permission. Team Integer's argument is all about efficiency and simplicity. An auto-incrementing integer is tiny, just 4 or 8 bytes. That makes joins and lookups incredibly fast. They're easy for us humans to read and debug, and here's the crucial part. They are naturally sequential. New data just gets tacked onto the end, which, as we're about to see, databases absolutely love. But then, Team GUID steps up with a really powerful calmer argument for the modern world. With GUIDs, any service, any offline client, any server anywhere can generate a totally unique ID without ever having to talk to a central database. That independence is critical for distributed systems. Plus, because they're random, they aren't guessable, which is a huge security win for your public APIs. So, it seems like GUIDs are the obvious choice, right? Well, not so fast. While GUIDs solve that big distributed problem, they introduce a hidden and, frankly, a really nasty performance penalty. The very randomness that makes them so useful is the same thing that can absolutely wreck your database's internal structure. To understand why, we have to pop the hood and see how databases physically store data. And this really gets to the heart of it, the B-tree index. Think of it like the database's super efficient table of contents. And in a clustered index, which is almost always the default for primary keys, the order of those keys literally dictates the physical order of the rows on your disk. Okay, picture your database table like a big 3-ring binder. With sequential keys like integers, you're just adding a new page to the very back. It's clean, it's efficient, and the binder fills up nice and neat. But with random GUIDs, oh my, it's a mess. It's like you're trying to shove new pages into random spots all over the binder. You constantly have to pull sections apart to make room, which leaves tons of wasted space. This is called page splitting, and it absolutely kills your write performance. And hey, you don't have to take my word for it. Here's a perfect summary from Reddit user MattSnake86, explaining exactly how this random insertion order leads directly to fragmentation and slows things down. This is a real pain point that developers feel in the wild. So, what does all this fragmentation actually cost? Let's talk numbers. In one benchmark that inserted 10 million rows, the table using those random GUIDs was a staggering 175 megabytes larger than its sequential cousin. That's pure wasted space, all because of those inefficiently packed index pages. But wasted space is only half the story. Let's look at what really matters: time. In that same benchmark, inserting 10 million rows with random UUIDs took 126 seconds. The sequential version? Only 82 seconds. That's a 35% performance improvement just from changing the key strategy. That's huge. So, are we stuck choosing between a fast system that's centralized and a distributed system that's slow? Not anymore. This brings us to the sequential solution, a way to get the global uniqueness of a UGID with the awesome performance of an integer. Meet UUID version 7.
The design here is just brilliant. It solves the problem by embedding a high-precision timestamp right at the beginning of the ID. This makes the keys naturally sortable, just like an integer, while all the random bits that follow still guarantee they are globally unique. It's the best of both worlds. And you can see it right here in action. Just look at these UUID 7s generated moments apart. You can literally see the timestamp part of the key ticking upwards. They're sortable, they're sequential, and they tell the database exactly where to put the next row, right at the end, nice and tidy. So now that we know about this incredible super key, how do we actually apply this knowledge to our projects? Well, that brings us to our final section, a practical framework for making the right choice. This table pretty much breaks it all down for the most common scenarios. For a simple monolithic app, a big end is still probably your best bet. It's simple and fast. But the moment you move to distributed microservices or need offline clients to generate IDs, UUID v7 becomes the clear winner. And of course, for any public-facing API, any version of a UUID is way better than an integer to prevent scraping and information leaks. Ultimately, the choice between an INT and a GUID isn't just about a data type. It's really a statement about your architectural philosophy. It forces you to ask a fundamental question. Are you just building a simple system for today, or are you laying the foundation for a scalable, distributed system of tomorrow?